Okay, hi. This is example 6 for our video series and the curve sketch. Now, what you can say about this function? Intercepts. So, y-intercepts, right? Y-intercepts, well, this is intercept, is equal to 9/2, right? So, the curve passing through the intercept, y equal to 9/2. And what else? Does this equal to 0? 2x squared plus 7x plus 9. This one is a b squared 49 minus 4ac is negative. Therefore, this will never be 0, right? This will be never equal to 0. Understand? If never 0 means what? This curve will cut nowhere for y-axis. It means that this curve is never cutting y-axis. No. Sorry, mistake. We learned from mistake. This curve is never cutting x-axis, right? Because it's positive. Wait a minute. This means this is bigger than 0, right? Bigger than 0, less than 0. Bigger than 0. It means what? It means what? It means the curve is. I shouldn't say this. I should say this, right? Yeah, that is better. That means the curve is never cutting x-axis. If the curve cut x-axis, the y is 0. So it never. So the curve either above or below. Alright? When you sketch the curve, you're looking for information. These are information. Right? It means what? It means the y never be 0. Okay? Now then asymptotes. The vertical asymptote. The vertical asymptote. The vertical asymptote is what? Of course, x equal to negative 2, right? Because when x equal to negative is not defined, it's infinite. And what else? Then you talk about the oblique, right? Oblique asymptote, and then you divide this equal to plus, you know how to divide? 2x, right? 2x squared plus 4x and 3x plus 9 and plus 3x plus 6, so 3. So this means y is equal to 2x plus 3 plus 3 over x plus 2. So that is rewriting of the function into this form. So obviously y is equal to y equal to x plus 3 is an oblique, right? Oblique asymptote. Alright? So this is my oblique asymptote. This is my vertical asymptote. Alright? So when you sketch the curve, I know that these will be two asymptotes. Let me put this one here. Okay. This is y-axis. This is 2 minus 2. This is vertical asymptote, and this is oblique. This is 3, right? 3 is intercepts. 3 is the intercepts, and the gradient is 2. Gradient is 2, something like this. So this is my oblique asymptotes. Okay. So we have these pieces of information. Intercepts never touch x-axis, vertical asymptote and oblique asymptote. So these are information, give us help to sketch the curve, but it's not enough. Then we have to show something else. What else? Let's see first what happens if x is approached to minus 2 from right hand side. If this is a vertical asymptote, and when x is somewhere here, right, that means x equal to what? Minus 1.9999999. So this will be what? This will be positive, isn't it? This is positive, very small. So this is an infinity, but positive. So x is approaching to positive infinity, right? So there's something here, something like this. Well, can you imagine? This is the situation when x is here, y is a very big number. And when x is approaching to 2 from left hand side, and y is, when x is approaching to negative 2 from the left hand side, so this is a negative 2.0000 something. So this result will be negative, but very small. So this will be, overall, it will be negative infinity. So this will be negative infinity. So that means somewhere here, right? Well, this is somewhere down there. Okay, very far away. Yeah. Do you see that? Somewhere here, right? When x approaches here, y is infinity, negative. And then also that when x is approaching to positive infinity, what happens y? When x is positive infinity, this means very big number. So this will be very small number, right? But positive. So y is this plus a very small number. This plus, so this one is a 2x plus 3, a little more than that. A little more than this. So that means my asymptote is here, right? When x is very big, y is a little more than this asymptote. Do you see it? You have to see it. And when x is infinity to negative, very big negative. When x is a very big negative, this is negative, very big. So this is a very small negative number. So y is this plus a very small negative. So that means y is approaching to this number, this curve, but below it. Somewhere here, right? Somewhere here. I should use red color. Do you see that? You have to see it. See, otherwise you cannot sketch the curve nicely. Right? So this is the situation for this. This is 2x plus 3, 2x plus 3 negative. Right? So that is this situation. And this is this situation. Right? This is this situation. Red color. And these are the other situation. Now, what else? If you don't have any other information, then you have to imagine that the curve looks like this. So somewhere must be a minimum. No, somewhere must be maximum. Here the curve looks like this, right? Somewhere must be a maximum. So we are searching for these two things by taking derivative. The derivative, right? dy dx is this derivative, right? That's equal to 2 plus something. 2 plus this derivative. Understand? This derivative is that negative, right? This is 2. So this is my derivative. And then let this be equal to 0, and you can find that x is equal to, this is very easy to solve, minus 2 plus or minus 2. Okay. So by changing this one to decimal, approximately minus 3.9, approximately, and minus 0.5. All right, do you understand? So I know that these 2 points may be maximum, may be minimum. Okay. What are the 3.9? Somewhere here, right? So this is really too big. This is a 3. This is a 4. And seems that my image is not very on scale. This is minus. This is no, minus 4 here. Minus 4 here. This is 0 point. This is 0. This is a 1, 0.6. Okay. How do we have negative? I think it's I'm miscalculated. This is not right. This is equal to. If you have a calculator, you can help me. This is minus 0.79, and the other one is minus 3.22. So this is 0.3. This is a 0 point. This is a 0.5. 0.5. This is 0.7. Okay. And now it's better. And then we're looking for y value, right? Function y is equal to this minus 0.79 is equal to well, my calculation is 3.9, and this one is minus 5.9. So 3.9 is somewhere here. This is 3.9 here. All right? This is a 4, and this is a 2. Okay. And this point is minus 322. Y is somewhere here, right? Yeah. So this is minus 6. Okay. So we have these points. One moment. We have this point is our minimum. This is the intercept, and this is the maximum. Okay. Now everything is all right. So this is minimum. This is maximum. All right. So finally, we draw the curve. The curve, the shape looked like this, looked like that, passing through this and the minimum, and this is maximum, and this is the curve. This is the curve. So obviously you can draw, right? The curve looks like this. See? Very nice curve. Well, you can imagine. And this one is, right? Wow. My hand cannot shoot. Straightforward, no? Okay. Is that beautiful? Beautiful. Very nice curve, isn't it? Now you can check the second derivative. The second derivative, which is not difficult to find, is this derivative, right? Is that equal to 6 over x plus 2 and the cube. Okay. This one you have information, it's never be 0. This one never be 0, right? This never equal to 0. Why? Because this is never equal to, obviously not equal to, which means what? No point inflection. The curve has no point inflection. And this was bigger than 0 when x is bigger than 0, right? This is less than 0 when x is less than 0. So you know what is positive, right? This is positive, this is negative, right? right? When x is positive, this shape. When x is negative, this shape. When x is positive, this shape. Now, x bigger than 2, huh? Less than 2, you see? Minus 2. When x is bigger than minus 2, it's positive. When x is less than negative 2, it's negative. So when x is bigger than minus 2, this shape. When x is less than this shape. Well, don't you think it's very nice? It shows all the information. This is great. Well, any question? I think it's a very nice curve. Very nice way of drawing it. Right? Very, very nice.